You are one of maybe a few thousand people left on Earth. Not because of a war, not because of a virus, because of a sky that won't clear. For years, maybe decades, the sun comes up gray. The rain doesn't fall where it used to. The animals you hunted are gone, or they've moved somewhere you can't follow. Your group is smaller than it was last season. So is every group like yours scattered across a continent that suddenly feels too big and too empty at the same time? Children are being born into a world with less food than the one their parents grew up in. Some groups simply go quiet. You never hear from them again, and you stop expecting to. The older members of your group talk about winters that didn't used to feel like this. Nobody has a word yet for what's happening, because nobody has ever needed one before. You don't know it yet, but you are living through the closest call your species will ever have. This isn't a thought experiment. This happened, and the evidence for it is written into your DNA right now, whether you've ever thought about it or not. Around 74,000 years ago, the Toba supervolcano on the island of Sumatra erupted, the largest volcanic event of the last 2 million years, ejecting an estimated 2,800 cubic kilometers of material into the atmosphere. Ice cores drilled in Greenland and sediment layers found as far away as Lake Malawi in East Africa show a volcanic winter that may have lasted years, with global temperatures dropping enough to collapse food chains across the continents where early humans lived. Ash from the eruption has been found blanketing sites across India in layers over 5 meters deep in places, and traces of it show up in marine sediment cores as far apart as the Arabian Sea and the South China Sea. For a stretch of years afterward, sunlight reaching the ground may have dropped enough to knock several degrees off the average global temperature, enough to shorten growing seasons, stress plant life, and push the animals that early humans depended on into decline right along with them. Here's where it gets strange. In 1993, geneticist Gibbons and population geneticist Lynn Jorde examined mitochondrial DNA diversity across living human populations and found something that shouldn't have been possible for a species our size. We were far too genetically similar to one another. Not similar like close relatives. Similar like a population that had been crushed down to almost nothing, then had to rebuild itself from whoever happened to survive. In 1998, geneticist Stanley Ambrose connected the two threads in a paper that reframed how anthropologists thought about this stretch of prehistory. He proposed that the Toba eruption triggered what's now called a population bottleneck, a moment where the entire human species may have dropped to as few as 3,000 to 10,000 breeding individuals. Not 3,000 in one place, 3,000 total. On the whole planet, across every continent humans had reached so far, from southern Africa to the edges of Southeast Asia. To put that number in perspective, a modern conservation biologist looking at a population that's small, of any species, would immediately flag it as being on the edge of collapse. Small populations don't just risk starvation. They risk something slower and more insidious. Inbreeding depression, where harmful genetic mutations that would normally get diluted across a large gene pool instead start showing up again and again, generation after generation, because there simply aren't enough unrelated individuals left to breed with. Think about the town you grew up in. That might have been more people than existed of your entire species. But the bones told a different story than the ash did, and this is where the science had to start proving itself rather than just theorizing. Researchers didn't take the genetic estimate on faith. They went looking for a population that had actually survived in a place that could have kept people alive when everywhere else was failing. In 2007, a team of archaeologists led by Curtis Marian began excavating Pinnacle Point on the southern coast of South Africa. What they found was a group of humans who had adapted to eating shellfish, using ochre pigment for what looks like symbolic marking, and crafting some of the earliest known finely worked stone tools, all dated to around 164,000 years ago. Well before Toba, but with evidence of continuous occupation stretching through the exact window when the rest of the world was starving. The coastline gave them something inland populations simply didn't have, a food source that didn't depend on rainfall or migrating herds. Tides came in whether the sky was gray or not. Shellfish beds didn't need a good hunting season, and unlike large game, they couldn't simply migrate away from a struggling group. Marian's team also found evidence that this population was tracking the tidal cycle itself, timing their foraging to the lowest tides of the lunar month, a level of ecological precision that suggests they weren't just surviving on the coast by accident. They had learned to read it. That's the turn in this story. It wasn't strength that got us through the bottleneck. It wasn't intelligence in the dramatic way we like to imagine it. No fire-forged heroism, no single brilliant invention that saved the day. It was geography, a strip of coastline that kept producing food when the rest of the planet stopped producing anything. A population small enough to fit inside a single stadium section, quietly outlasting a catastrophe that erased almost everyone else who might have become human alongside them. And here's the part that should actually unsettle you. Every person alive today, all 8 billion of us, carries the genetic signature of that bottleneck, whether their ancestors were on that coastline or not. Population geneticists have found that human genetic diversity is a fraction of what you'd expect from a species our size, age, and geographic spread. Chimpanzees, our closest living relatives, show more genetic variation within a single social group than humans show across the entire planet. That's not a metaphor. That's measurable, published, peer-reviewed data. You are, genetically speaking, closer to 7 billion strangers scattered across every continent than a chimpanzee is to the chimpanzee living one valley over. 2 people picked at random from opposite sides of the planet, different continents, different ancestries, no shared language, will still share a vastly higher percentage of their genome than 2 chimpanzees from neighboring troops in the same forest. Population geneticists sometimes describe this as looking, genetically, like a single extended family that's scattered recently and hasn't had time to drift apart yet. Because in evolutionary terms, we haven't. Some researchers have pushed back on the Toba bottleneck specifically. A study published by archaeologists working alongside Marian's team found stone tool layers in the Horn of Africa, showing continuous human occupation directly through the Toba ash layer, suggesting at least some populations weathered the eruption better than the strictest version of the bottleneck theory implies. The debate over exactly what caused the genetic squeeze, Toba alone, a string of climate shifts stretching across tens of thousands of years, or some combination of the two working together, is still very much alive among specialists, and probably will be for a long time. But the squeeze itself isn't seriously in question anymore. Something somewhere between 100,000 and 70,000 years ago brought our species down to a population so small that modern conservationists would classify it as critically endangered. We were, by the numbers, rarer than the black rhino is today. Rarer than the mountain gorilla. Rarer, in fact, than most species currently listed as critically endangered anywhere on Earth. And it likely didn't happen just once. Some genetic models built from comparing mutation rates across thousands of modern genomes suggest multiple smaller bottlenecks stacked on top of each other, going back even further into deep time. Moments where a drought, a disease, a single bad decade of hunting could have quietly ended the entire experiment of us. Some researchers have pointed to an even earlier squeeze, over 900,000 years ago, where certain genomic models suggest breeding populations may have dropped into the low thousands for an extended stretch, long before Homo sapiens even existed as a distinct species, in one of our direct ancestral lines. No dramatic extinction event, no asteroid, no single villain to point to, just slow attrition, generation after generation, until one line held on long enough to become everyone, and the countless other lines simply didn't. Which means the reason you exist has almost nothing to do with your ancestors being exceptional. It has everything to do with them being lucky enough to stand on the right strip of coastline at the right moment, with the tide still coming in on schedule. Your instinct to crave salt, your body's strange, specific comfort near open water, the way coastal air seems to slow your mind down without you being able to explain why, in a way that mountain air or desert air never quite does. Some researchers have wondered aloud whether that's an echo of the bottleneck itself. A nervous system still quietly, wordlessly grateful for the one landscape that didn't turn on us when everything else did. It's speculative. Nobody can prove a feeling is a memory that old, but it's hard not to notice how many people, across cultures that never touched each other, independently decided the ocean was where you go to think. You don't remember any of this, obviously. You couldn't possibly. It happened roughly 2,000 generations before your grandmother was even born, back when the very idea of a grandmother, a woman living long enough to help raise her grandchildren, may have still been a relatively new experiment for our species. But your body was built by the survivors of it, shaped by a filter so narrow that almost everyone who could have existed instead of you simply didn't. So the next time the sky looks a little too gray, or the world feels like it's asking more of you than you have left to give, remember this. Your entire species has been here before. Smaller than you can really imagine. Fewer people alive at one point than fill a mid-sized stadium on a Tuesday afternoon. Closer to the edge than most history books admit, and closer to disappearing entirely than almost anyone walking around today has ever stopped to consider. And somehow, against every reasonable expectation, it still found a way to the shore.